Welcome to this C# support video. This is designed for A-level computer science students. It kind of serves a double purpose. I want you to improve your C# skills, but also this is part of the compression, encryption and hashing topic for your A-level. We need to understand run length encoding. So it's a form of lossless compression, which means you can reduce the size of something without reducing any of the actual detail. So for example, if you have lots of repeated characters, rather than writing them out in order, it makes sense to spot the pattern. So 6B means we've got 6 B's in a row. This could be like a black and white image for 6 black pixels and then 6 white pixels, so 6W, and you get the idea. So it's a way of compressing things if you have a lot of repetition. If it went BW, 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 then actually you'd need to say like 1B, 1W, 1B, 1W, which would end up with a compressed version even longer than the original one. So it's not a particularly efficient form of compression, but it's a nice easy one, and it comes up pretty regularly in your A-level exam. So how can we implement it? Well, we have a function called RLE compress. We have a string like this with lots of repeated characters, and we need to output something like that with spaces in between each pair, but no space on the end. So we're going to need to iterate through every character. So for I for index is 0, that means we're looking at the first character. I is less than the length of this input. So input is a parameter that we receive. And then increase I by 1 each time. Then we should keep track and see if the character we're looking at is the same as the character we've previously been looking at. So we need to keep track of which character we've been looking at previously. Let's call it previous char. And I'm going to use something that doesn't come up. I've said here you can assume that it only contains uppercase ASCII characters with no spaces, punctuation or numbers. So if I say that the previous character was a space, I can be confident that that has never come up so far, which is quite useful because then we can compare what we're looking at the moment, as in the input string at position I. If that matches our previous character, then we need to output the string here. So, right, how can we do this? Well, we only want to return a single string, but we need to add to it for each character that repeats. So that means we're going to need to keep track of the RLE string, and we'll make an empty string to begin with. Okay, so when we detect a new character, that's basically what this means. When we detect a new character that's different to the one we've detected before, our run length encoded string is going to be what it was plus, as in concatenated onto the end of it. Right, how can we do this? We need a number and the previous character. So I'm going to do this with string formatting. Otherwise, it might try and add on the numeric values instead here. So string format, what do we want? We want a number, and then we want a character, and then we want a space. So what's the number? Let's call it count and say int count equals 0. So this is basically saying we've had 0 spaces. And then if we do detect a different character, we want to make sure we reset count back to 0 so that we can count how many of the next character we have. All right, will that work? I have no idea. I guess if that's not the case, then count increases. And then at the end of the loop, so after the loop here, we want to concatenate onto the end of our RLE string. The same kind of thing, but without the space on the end. So what have I forgotten? This is the count, so that's like 6 out of 6B, 6 blacks, 6B characters, but I haven't got the character here. So what's the character? That would be previous character. Would that work? I think what we want to do in here is then update the previous character. So the previous character, at what point do we need to update it? Let's see, if the character we're looking at the moment is equal to the previous character, no, I think it's the other way around, isn't it? If it's not equal to the previous character, we reset our count and display, but if it is equal to the previous counter, then it means we've counted the previous character. That means we get an extra character to add to our count. And in here, the previous character is equal to the character that we just looked at, so that we can compare it next time. Ugh, no idea if this is going to work. Let's have a look. No, what have I done wrong? Line 11. Yeah, there we go. Nice and easily fixed. The name prevchar does not exist on line 8. I think I should have called it previous. But let's just go for prevchar up here because I've used prevchar twice. Oh, oops. What now? The name previous character doesn't exist on line 7. Oops. More problems. Let's have a look. Oh my goodness. There we go. Still no joy. Okay, so what's happening here? We've got a string that we add the details onto, but we never actually return that. Still no joy. Right, so what's happening here? This says we should have 8 G's, so it should be that, but what I'm getting is 0. Oh dear. So let's see. If what we've detected is not equal to the previous character, I guess we should only output this if count is more than 1. So if count is more than 0, then we'll display it. Otherwise, we set count back to, I think count needs to be 1 at that point, because we've just had one of those characters. Let's have a look. Yeah, awesome. Okay, so let's have a look at the logic here. Most important thing, run length encoding means if you've got a repeated character, you can reduce the amount of storage space required to represent that sequence of characters by saying the number of times it repeats and the thing that repeats. To implement it, we've just got to loop through each character, check and see if we've come across that character before, and then output the number of times it occurs and the actual character that occurs, and make sure that we reset the count back down to 1 and keep track of the character that has previously occurred. Okay, I hope that's helpful, and I hope it explains a little bit about what run length encoding is. All the best. See you next time.